Welcome, welcome. A few more people have attended. We give folks a few minutes to join us, and then we'll jump into it. I see some folks that have been in here 3 times over. Welcome back. Game Masters, don't be shy. Feel free to chime in.
Yeah. Got a wild T-Maxer has appeared in the participants list.
We see you, Tommy.
Yes. Hey, Tommy. Samantha, welcome back.
It's right in the panelist list or the participants list.
Chris is here, everyone, so you have to be on your best behavior.
Darn.
We'll take another 2 minutes or so. Let some more folks join us. Chris says hi. Hi, Chris. Nick has also thrown a link. Nope, that's not for everyone, or is it?
Oh, I put it in the wrong place.
Yeah, Nick is going to share a link. If you want to follow along, use this link.
That's a good opportunity to point out, by default, if you want to send a chat message to everyone, if you have something to share, you can change the chat mode from panelists to panelists and attendees. That's how everyone will see it. If you just want to send a message to us, obviously you can just send it to panelists. We'll get into how to ask questions later on, but.
Yep.
Yeah, we got some familiar names showing up. That's cool.
Mm-hmm.
It is Leah. I work with her.
Hey. I'm going to go ahead and share my screen, and we'll go ahead and get started. I imagine there's quite a bit to get to. Give me 1 second. All right, how are we feeling? We're ready to get started? Thumbs up. We feel good about this? It's happening. All right. Hello, everyone. Welcome back to the 3rd iteration of JOLT.ed. This is the 3rd part in this 4-part series. Typically, this time of year, we are hosting JOLT. If you've been to any of the other few of our JOLT.ed series, you've heard me give this spiel. Typically, this time of year, we're doing JOLT. This is a 200+ person event. We take over a local downtown spot that can accommodate that number of folks. You split up into teams of 4. There's tons of food. It's a weekend-long event, and it's all about camaraderie, but also about competition, friendly competition, hacking puzzles that our wonderful game masters put together, and just a weekend full of fun and learning and all kinds of experiences. Unfortunately, we're not able to do that. So in its place, we have JOLT.ed or JOLT.ed. And this is, we listened to your feedback from previous surveys of JOLTs, and you guys said you wanted that educational component. So even though we can't do JOLT, we at least want to bring you that educational piece. And that's kind of how JOLT.ed came to be. So this session is all about web vulnerabilities. And today we've got Daniel Spillers, who will be our MC of this event and moderator. We've got Nick Seward, Josh Baugh, and also Ben Allen. He's one of the game masters I don't think you guys have met yet. So excited to have him as part of this group today. and we'll roll right into it. Do want to give you a look at what's going on. We've done the encoding and ciphers session. That was October 8th. Then we moved on to the hacking puzzles last week. That was October 16th. Today is all about web vulnerabilities. And then next week, Friday, November 30th, from 11 to 1, we've got reverse engineering. So if you haven't registered, go ahead and register for that. Those who register get the recording. It's also shared on Discord, which is that JOLT Discord channel that has been shared in all the emails. So be sure to register for that one, and we'll see you next week for that one. I did mention the Discord link. Go ahead and join us there if you haven't already. We want to keep the conversation going all about JOLT. Hopefully, fingers crossed, we can do an actual physical JOLT competition next spring. But we'll obviously let you guys know more about that as we get closer. But go ahead and join that Discord channel, and that way you can ask questions to the Game Masters and keep those conversations going on all these topics that we've covered throughout this series. Do want to give a shout out to our sponsors. None of these programs and series could be put together and done without these awesome sponsors. So big thank you to Wright Lindsay Jennings, Simmons Bank, Mainstream, the Little Rock Regional Chamber, Frost PLLC, Euronet Worldwide, and First Orion. And I do want to take a second and recognize one of these sponsors who's actually here with us tonight. We have Carol Smith with Simmons Bank. So I'm going to turn it over to her real quickly, and she can talk a little bit about Simmons and why they chose to sponsor this program. Carol?
Thank you. Can you all either hear me or see me? I have a little spinning wheel in my
We hear you. We see you.
screen, so I'll make sure you can hear. Okay, good, great. I'm Carol Smith. I'm a senior vice president in our commercial group here in Central Arkansas. Simmons Bank, if you're not familiar with us, we're a $21 billion regional bank with locations in Arkansas, Missouri, Kansas, Oklahoma, Tennessee, and Texas. So we're about anywhere that you might want to be in this part of the country. It is our honor and pleasure to be a financial partner with the Venture Center, because we so strongly believe in the what the Venture Center is doing for us in Central Arkansas and all of Arkansas to promote economic development, which is what our bank is all about. So we're a proud sponsor. We're a full service bank. We hope contests and changes that Venture Center has to offer, because we are really proud to be with them.
Great. Thank you so much, Carol. And like I said, we couldn't do this without sponsors like you. So we appreciate you, not only sponsoring, but being able to listen and hear this and be a part of it.
Yeah.
So thanks for joining us tonight.
Thank you.
And with that, I'm going to go ahead and turn it over to Daniel Spillers, who is the moderator for tonight's event. Daniel, you can take it away.
All right, welcome everybody again. We're really glad that you're joining us for our third of a four-part series. I wanted to take a moment and remind y'all how to use the chat and use the Q&A tool. That's how we'll try and collect your questions. If you have anything you want to share or reaction or questions, you can change your chat mode to where it says panelists and all attendees, and that will get to everyone. Obviously, you can send us direct messages if you need to, but the Game Masters will probably be ignoring you, so I'll be the one trying to pay attention. You can also use the Q&A tool to post a question that you'd like us to answer at any time, and then I'll either get to the question there in chat or pause the Game Masters and ask them to answer it right here. We want to gather all your questions. And finally, like Ashley said, I want to invite you to the Discord server. That's really where we want to keep talking to you after these events and throughout the whole year. We need your feedback on ideas, and we want you to have the ability to talk with us and each other as we ramp up to the next JOLT. So without further ado, today is our web vulnerability session. We're here to talk about some of the basic vulnerabilities that hackers can exploit on insecure websites. One of the reasons we chose the web vulnerability topic is that that's one of the more popular puzzle categories at JOLT. I kind of call it a gateway category because almost all the challenges in that category will use a web browser as the main inspection tool and the main piece of software that you interact with websites with. And it's just a really easy way for people to get started at kind of that sense of uncovering flags and uncovering things without having to come into the competition with a lot of previous experience or a lot of understanding about how to use the more technical tools. So today, to start us off, Josh, the Game Master Josh, will be sharing a video and a story that is definitely not a true crime story, that he definitely actually did do, about defensive driving and some offensive web inspection. So Josh, I will pass it over to you and we'll see what you've got to tell us.
All right. Hey, everybody. So the other guys really do have some fantastic demo content that we're going to get to here in just a little bit. But I wanted to tell a little bit of a story to give you a real world example of things that I've seen in the wild. So let's say that your name rhymes with Josh, and maybe it's about exactly almost 3 years ago. And you're driving back from the beach in Florida, driving home with your family. You've got 2 small kids in the back that are completely asleep. Your wife's in the passenger seat, she's also asleep. And you're in rural Louisiana, and you're driving and the speed limit is 70 miles an hour. And you may or may not have been doing about 98 miles an hour. And you get pulled over, and the officer tells you that he thinks you were doing 85 miles an hour. And you say, okay, sounds fine. And then you get the ticket and you call the city and you find out like, hey, those are some nice insurance rates you've got there. It'd be a shame if something happened to it. So then you get the opportunity to pay some money and do an online defensive driving class, which is, number one, that's super cool that they even offer that. And then I'm able to do that. I didn't have to go to court in Louisiana where I don't live. So that's great. You log in, you pay your money, and then you log in. And then they've got a really great course there. It determines what kind of ticket you got and chooses which video segments you are presented with based on that. That's pretty great. They do a lot of session tracking where the video is pretty long. You know, it's like 2 hours or something. And there's a mandatory test at the end. So you don't want to miss any of the content. You don't want to fail this test and then have to pay for the course again and all that crap. So you're watching this video. It's really long. It's riveting information, as you can imagine. And for some reason, you might have fallen asleep for like 20 seconds. And then you wake up, you jolt awake even. And then, and because you don't want to fail this test, you think, well, crap, I need to see that content. And luckily, the website's pretty nice. They got a nice UI. They've got a button to like skip back a minute, skip forward 30 seconds. You can pause it. You can leave the page and come back, and it resumes your session exactly where you were. That's great. Except you hit the button to go back 1 minute. And it instead goes back to the absolute beginning of the whole course. And nobody has time for that. You're not going to do that again. Well, a lot of people aren't going to do that again. So that won't do. And you think, hey, they're doing session tracking. I know that's what they're doing because that's how I'm able to do this. So how are they doing this? And is it possible for me to skip right back to where I should be? And you find out, yes, you totally can, because they're doing client-side tracking. They're setting a cookie in your browser. So you pop open your web developer tools in your browser, you examine what the website has stored locally for you. You see all of a sudden that there is a cookie value that is constantly updating as the video is being viewed. Just like this. So there's our fantastic trooper At the bottom, we've got our web developer tools, and let's pretend like we don't see this website. And then we scroll across here, and we see that this value is just constantly updating. And that is exactly the number of seconds into the, or seconds, or however they're doing it, into the video. So all you have to do is edit that right in the browser, and it'll skip to exactly that location. So you just play with that value a little bit and get exactly back to where you need to be. Watch the last 20 minutes of the video, take your test, pass, and you don't have to watch that stuff again, and it's great. So that's just a bit of a peek into some of the stuff we're going to get into tonight, and it was an absolute real-world life-saving skill to have. Life-saving might be a little bit of a stretch, but it was to me at that particular time. So I'm going to hand it off to Ben.
All right. So thank you, Josh. We will protect the innocent, I'm sure, and not share this video with everybody that is joined. So next, Ben and Nick are going to show you, to dig deeper into this idea of inspecting various websites to see how they interact or see how the client interacts with the websites and different things you can do. They're going to show you a number of ways that a very determined Twilight fan named Alice was able to bypass a number of websites to get exactly what she wanted. Because Alice has a computer, she's got a lot of free time, and she's got a mission to live, laugh, and love. So Ben, how about you start us off and tell us what Alice did first?
Sounds good. I will take over screen share. There we go. So try not to be too blown away by our amazing graphic design. I assure you, this is amazing, and you will love it all. So just like Daniel said, Alice is a very determined person. Alice, like all of us, wants things, and she's very determined to get the things that she wants. So the first thing today that Alice wants, which is going to branch right off of Josh's story, is Alice wants cookies. Alice is a participant in the Fall Festival Food Fundraiser, which is a raffle that she can enter to win all sorts of tasty confectionery treats. And Alice wants to make sure that she wins. And the site that she's using has a vulnerability that she will exploit to do so. So Alice arrives here at the Confectionery and Cookie Consumption Contest login page, wherein you enter your username and it stores some cookie values into your computer. So you may ask, now what the heck is a cookie? Even though I see all those pop-ups on every site I go to about cookies, what actually are they? So cookies are just files that the web server is able to store on your computer. It's usually used to persist, local settings. Say I prefer a website with certain like light mode or dark mode. Cookies will preserve that setting. So when I visit again, I don't have to set that setting over and over and over. This is all well and good. The problem comes when developers use cookies to store more sensitive data. Since cookies are stored locally, they can be edited by the user. And if the user is malicious, then they can potentially leverage that access, especially if the cookie is too powerful, quote unquote. They can leverage that access to gain more control over their situation than they should have. So this site works pretty simply. We're just going to say, Alice is just going to try and log in first. And she put in her username, hit the submit button. And right now, this isn't very helpful. It just says, hey, Alice, well, stay tuned for the contest results. It's coming up soon. But Alice really wants to know what the winning ticket number is going to be. Because if she knows the winning ticket number, then she can make sure she gets that ticket and she can win all of those tasty, delicious confectionaries and cookies. So Alice starts poking around in the browser. And one of the first things you can do when the browser seems to be persisting your information is you can check out what the cookies for the site are. So I'm about to show you the only non-browser tool we're going to use today in this video, in this webinar, is a little extension that just makes life a little easier. It's called Cookie Editor. And with this, say I can edit the contestant cookie value and change Alice to Bob, save the value, and then reload the page. And we note that our name has changed. So that cookie is being directly used to influence what the page shows us. The astute among you will have noticed the cookie right above that says admin cookie. That seems like a good candidate for an attack surface. So we note that it has a value of 0. And we can change it to a value of 1. Seems reasonable. When we do that, and we reload the page to get the cookie changes to apply, we now have the winning raffle code. Our winning raffle code is 271828. And now Alice has all of the tasty cookies that she could have ever want. So this is going to be this is like the kind of the first of a point that we're going to spend a lot of time in this talk drilling home, which is you don't want to trust what the client is giving you too much. If you're a web application developer, anything critical shouldn't be managed by the client because the client can take over.
So Ben, I'm guessing most developers wouldn't actually make a cookie named admin. Like what would be a real attack that could leverage this?
So a more common scenario might be you log into a website and you check the box that says keep me logged in. And that might involve storing a cookie that saves maybe it just saves your username and some authentication details. If you know the username of another user and if the site doesn't do the proper checks, you could change the username that's on that preserve my login status cookie and essentially log in as another user. That's one type of attack surface you might see in a real JOLT challenge.
So now that Ben has made sure everybody's awake with that amazing sound effect, before we move on, I'm going to ask a few questions of the group since we have your attention. First, so we're going to ask you to answer a poll here. We want to know if you've ever participated in one of our JOLT cyber challenges in the past, just to get a sense of who we're talking to.
Oh, I can't vote.
While we're waiting on the results, Ben, could you talk a little bit about, since we know you have a really good example about changing users based on stored information, what could something like a malicious browser plugin do?
Oh, certainly. So since this is all local data and the browser has to access it, plugins that you grant access to your cookies could also read them and could hoover up your login credentials for all sorts of sites that you visit. Anything that happens to store that stuff in cookies could be a target. So that's why you want to carefully vet the extensions that you use on your browser in general. Just like you should carefully vet any programs that you allow on the computer.
Okay.
Josh says no. Josh says don't vet.
Before we move on, we also have a second question. We just want to now you've just learned a little bit about cookie and header inspection and things like that. But we want to see how much of these various topics you've ever heard of or had any experience with. All right.
Now go to bed and hope you don't see this image in your dreams.
That's right. And just to give everybody a sense of you're in good company. So we've got a great spread of experience here. All right, Ben, back to you.
All right. So I'm going to jump right into the next challenge. So our next scenario is Alice really loves to read. She's read every book at the town library. And Alice really, really likes Stephanie Meyer books. She loves the Twilight series. Can't get enough about books about vampires. So in case you weren't aware and you've been living under a rock, there's a new Twilight book out, which I definitely did not learn on Tuesday when we were making this. And Alice wants to rent that book from the library before anybody else can get to it. She has to be the first one to read it. This book is the talk of the town. So when Alice goes to the library site, she gets to enter her username, first name and last name for the system to address her by. And then since she's registered as a premium user, the login form allows her to select the free, standard, or premium account options. So we'll give a demonstration of what that looks like. We'll say her username is Alice, her first name is Alice, and her last name is also Alice, because I'm very creative. So she selects user type premium and hopes that maybe the book is here and we can get access to it at least before all the people who have standard and free access. They should get access to it later. So we wind up on this page. And when we head over to the new book access link, well, that's pretty disappointing. There's no new books yet, and she'll have to wait until tomorrow for her chance to get her hands on Midnight Sun. But Alice knows there's a lot of people with premium accounts at the library, and so her chances of getting the one copy first are not very good. Alice is going to improve her chances. And the way she's going to do that, if the page will go back,
Index.php.
Yep. Yeah, got me there. Okay, there we go. All right. So the way she's going to do that is we can theorize, and one of the first things that we should do, especially if you're at a JOLT challenge and you're just given a website and told, hey, figure this out, you know, there's something here to get at, but you've got nowhere else to go. Well, the first thing you can do is always open up your developer tools on Chrome or any Chrome variant. That's usually going to be Control-Shift-I or some flavor thereof. And that will drop you into the debugging window that you can use both when you're building websites and when you're attacking them like we are. So we can look at all of the HTML elements on the page, and we can manage them and handle them in certain ways. We can run JavaScript code in the console, and Nick's going to show you a bit of that in a future challenge. We can look at the exact files the server sent back. We can see the cookies. We can do all sorts of things. For this attack, we're going to focus on just modifying this HTML because we can guess that maybe the programmer at the library site wasn't the best about validating what comes back from the client. And so if the client sends a response, the server might just accept it and never check that that's what the client really should be doing. So one of the things we can try is that we notice they've got these types of drop down options in our drop down menu. Maybe we can just add another one, Alice thinks. Maybe I can just add the next level up and see if that gives me better access. So I can pull up the exact select element that's running this drop-down menu. And if I open it up, I can see that there's the 3 options for free, standard, and premium. And isn't that interesting? There's another option that's been scrubbed. So since this is client side, we can make changes to it and they will show up right as we do them. So we're going to edit this element as HTML, and we're just going to add another option. So our options are valued 1, 2, 3. So it's a reasonable guess the next one would be valued 4. And because we can name our access level whatever we want, I'm going to call it Ultra Mega Access. Close out our option. We save the changes. And it's now here in the developer tools, and it's here on the page. So we hit Ultra Mega Access. We fill out our form again, and we hit submit. So it didn't immediately kick us out. That's a good sign. We've kind of tricked it. So maybe our new book access link is good. And it turns out it is. We can reserve the copy of Midnight Sun before anybody else. That never gets old.
So I'd like, before you go on, I guess I'm next, but there's this one time I was ordering something online. This was quite a while ago, before Chrome had all the nice developer tools. And I came to this form where I was trying to order something, and it didn't have the drop down for the year on my credit card. And to be able to make that work, I had to add the options. But at that time, I was using Firefox, and the only way to change it was to get an extension called Grease Monkey. And so in Grease Monkey, I could go in, I could add the extra drop down, got the year I wanted, was able to order my item, and I got it. And then I sent an email to the company to tell them they need to fix their order site. Mm-hmm. But yeah, I've used this on a number of times in the past.
So after you went through all that trouble, was the Twilight book worth it?
I think Alice enjoyed her Twilight book. That's what I'm telling myself. I hope
No,
it
I
was
meant
good for her sake.
that question was for Nick.
Oh yeah. I was ordered. Let's see.
Sweet. I will hand it off to Nick.
All right. Am I sharing?
You are. And if anybody has any questions, feel free to add them to the chat or pop up in the Q&A tab.
All right. Alice loves coffees. She especially loves this time of year when she can get her pumpkin spice lattes, which are her fave. And anyways, so she sees over at the Starbucks site that there's a way that you can redeem codes to get free pumpkin spice lattes. And it doesn't stop you from just typing any numbers that you want. And so you could just try it out and hit redeem, and it says error, invalid code. And she really wants her pumpkin spice latte, and she's, she doesn't have the $15 it costs to buy it. So like with any web page, whenever you're coming across it and you want to exploit it, you want to look at the source. So let's view the source for this page. And there's a lot of stuff, header stuff. Up here at the top, you can see that it links to another JavaScript page. We might come back to that. There might be code on there that we want. There's some styling, lots of junk. But if we keep on kind of going through this, we're going to see the button where you hit submit to redeem your code. It says, hey, whenever you on-click, call the redeem function. And so that's the function we want to go check out, and we want to see how it works. Maybe we can exploit something in it. So since I saw that there's this file called code.js, I could click over there and see if it has the code that I want. So I'm now over this, and it's not nice and formatted right. So I'm going to show you a slightly different way to go at this with the developer tools. This is definitely fine. You can look through it and see what you need. But let me go back and do what Ben did. So Control-Shift-J is usually what I do to get the JavaScript console. And so you can, like Ben was showing you, you can look at, you can type in JavaScript commands here on the console. You can go to the sources and you can see all the things that were loaded up for this web page. So you can see here, there's not much. Code.js is one of the files that got loaded up, and you can click on it. And on top of that, it gives you code, nice syntax highlighted, and you can even go in here and edit things if you want to, which is pretty amazing. So we're gonna look through redeem and see how it works. All right, let me make it a little bigger. Okay, so kind of hard to do. Okay, so if you're looking at this redeem function and you've done any web programming, this should ring a bell that this is Ajax programming. What I mean by that is it will Ajax is a method where you go out and get a web page behind the scenes, grab it, and get the results, and then you can do whatever you want with it. In this case, I'm going to go and try to get the code to get a free coffee and come back with it. And so down here on line 19, it says, hey, go get this page verify.php, and it's giving the code to that web page, and it'll tell me whether that code is good or not. I'm guessing since it says verify. And above it, it's kind of backwards. You set what's going to happen if that comes back. And so if it comes back and the response text is good, then I can set it to be verified, and I can go call another function called getLink. And otherwise, you can print out error, invalid code. So there's a lot of things we can do here to mess with this. The first thing is I'm just going to directly try to call getLink and see if that's going to work. So I can go to the console and I can call getLink, and nothing happens. But I can also look at the line above it and it says verified equals true. So if I could just manually set verified to be true, maybe I can get away with this. And I can say verified equals true. And then I can say get link. And huzzah, I get my free link. Now, coming at this a slightly different way, it's possible that all this code is in a different scope. What that means is whenever I'm in the console, I'm not always going to be able to be allowed to type in these functions. Sometimes they'll be somewhere I can't get to them, but I can get to the source. And what's cool about that is I can just rewrite this function however I want. So I can come in here and change this code and just make it where if the response text isn't good, I can make it say verified's true and call get link. And I think if I hit Control S and save it, it will reload it and do a live swap. And now it'll be running that JavaScript. So I can try to type in a code here, hit redeem, and huzzah, now it's going to run the way I want. And I get the link and I'm good to go. So if you have access to, if you have access to the JavaScript, then you can change it, make it do whatever you want. So. All right. And I think Ben's up next, unless we have some questions. All right, Ben.
All righty. I'm taking over your screen share. This is a robbery. Okay. So our next couple challenges are going to be about the very broad topic of SQL injection, or you'll frequently hear me call it just SQL injection. So that is the broad idea of the attack is that we're going to exploit the website trusting our input into text fields and allowing that input to be directly copied into a database query. If we know that happens, and if we can find a way to exploit that access, we can change the database, we can learn more about the data that we're looking up than we're supposed to. And in general, you can make a very bad time of a web developer site if you can successfully execute SQL injection. So our premise for this one is that Alice and her family have been volunteering at the school's PTA, and well, she's noticed there's this really cute single dad, and she really would like to get his number, but she just can't seem to actually find the time to ask him for it. But the PTA has set up this members page where all the members can log in and just see what the status of various items are. And so Alice thinks maybe I can find out this information on the members page. So let's bounce over there. So the member management page is a login based on an ID number that you are given and then a password that you set. Or if you've forgotten your ID, you're asked to enter a username that you can use to look it up. So Alice, first off, doesn't remember her own ID. So we're just going to look up what that would be. So her username was Alice. We submit. And the page spits back that, hey, Alice, your ID is 5. And by the way, here's your phone number. Stepping back a bit, this website, for the clarity of this first example, is actually showing us the query that's getting run on the database. And so this would not, hopefully, never be the case on an actual site you're asked to attack. But for the purposes of this example, we're gonna see the query that's running, and we're gonna be able to walk through why it's exploitable. So the query essentially just says, get the ID, username, and phone number from the list of users where the username is Alice. And what we notice is that Alice is the input that we added, and it just got injected straight into this string. So we're gonna exploit that out of character. Back in character, maybe Alice pretends she doesn't get to see this query, and so she can log in. But that's not getting her anywhere. She really wants this other guy's phone number. So maybe who doesn't keyboard mash a little when they get frustrated, right? Alice just jams the keyboard. And, oh, would you look at that? The page broke. So even without seeing the query, usually a page breaking when you jam with some malformed input can give you an idea that something is wrong. And since this is a challenge about SQL injection, then we can rightfully assume that that's going to be the problem. So what we can do is the where statement of a SQL query basically acts as a filter. So we're filtering on all the usernames that are equal to Alice. There's only one in this database because all the usernames are unique. We can basically take over this statement from this character onwards, and we can change what our where clause says to grab every row in the table. And that's pretty cool. So how do we do it? Well, we notice that after we enter Alice, a quote gets added to close out the string. So once the page loads and lets me go back, we will exploit that. So we're going to enter our username as Alice again, but this time we're going to manually close the string and basically start adding stuff to the filter statement to retrieve more results. So one of the oldest tricks, if you're getting a table printed out at you, then you can retrieve the entire table just by saying where Alice or 1, and then ending the statement and killing all input after that. And essentially what this is saying is grab all the users in the table where the username is Alice or 1 equals itself. So that's going to grab every row in the table. The semicolon is to close the SQL statement, and then the double dash and space are to comment out everything else so it doesn't break the rest of the query. So the server is going to get this and treat it exactly as a query. And we've retrieved every record in this table. And hey, there we go. There's Single Dad. His phone number is 8675309. I think this image is my favorite. Okay, before I go on to SQL injection part 2, questions from QA or GMs or any of that?
So Ben, how do web developers kind of protect against that particular form of attack? What are some things that you'd have to do? Or let's pretend that you were in a defense mode and you saw somebody doing this, and then you needed to come through and fix it, and prevent it.
Yeah. So for web pages, we pretty much always want to use what are called prepared statements, which basically escapes the input that the user is putting into that text field and surrounds it with its own quotes and does safety checks on it to make sure that we can't hijack the statement like we just did.
I would like to point out that there's a massive amount of legacy projects that don't use prepared statements, number one. Number two is PHP doesn't throw any massive warnings or prevent you from not using prepared statements.
Right. It just treats it as this is normal and fine.
So if people don't know better and they just go get here's how to do a SQL query from the internet, and they don't think too much about security, they could easily do it the wrong way.
It's easy to foot gun yourself with this and do it to yourself, especially if you're a new developer. I think it's estimated that the #1 vulnerability facing most sites is going to be this exact kind of attack.
By far,
or more advanced variants.
Even today, yeah.
Yeah, even today.
And I also really like that, as far as a game player at Jolt, one of the first things, especially if we give you the category, one of the first things to do is to try and submit gibberish to sites, and you're starting to kind of forensically see how the site reacts to certain inputs. And I think over time, participants get clued in on what kind of inputs or what kind of gibberish works to kind of uncover some vulnerabilities like that. So that's why I really like this example.
You'll notice when I keyboard mashed, I did an extra character at the end. That was the single quote to make sure I broke the statement and didn't just you know,
I
accidentally
totally
submit
didn't
good
notice
gibberish.
that.
Yeah, if you're looking for characters to check whenever you have a box, you should always try single quote, double quote, backslash, forward slash, number sign.
Yeah, double dash for commenting out stuff. Yeah.
Yeah, any of the special
All
characters.
sorts of special characters you can try to break queries with. Okay, so our next challenge and the last one from me is going to be basically part 2 of SQL injection, where we get a bit deeper into it. Our setup for this one is that, like everybody, Alice loves motivational signs. Who doesn't? And she really wants to. She really wants more motivational signs, but it kind of gets to be a strain on the budget after your 50th or so. So Alice has decided that, well, if she could just add a coupon to maybe the Hobby Lobby coupon database that she knows the code for, then, you know, she could give herself a buy one, get one on live, laugh, love signs. And that would just be the best thing ever. That would slash the live, laugh, love budget in half. So that's exactly what Alice is going to do. The Hobby Lobby site is also pretty simple. It's basically just a place for you to dump your shipping address when you order things. So Alice is going to go and create a new user. Username is going to be Alice12345. And I'm going to call that her password as well. Don't tell anybody. Shh. Okay, so once you've created your user, it dumps you to this page. Welcome, Alice12345. You can enter your shipping address and it'll get updated there so that when you buy stuff, it'll get shipped to you. So Alice is going to update her address. It's 123 Alice Drive. Huzzah! So the stuff we entered in that text field got sent to the database somehow and saved. So stepping back out of character here, what this challenge is going to be is we're going to hijack the statement that's changing data in the database to change more data than it's supposed to. Out of character, this would be a longer process, it would be a longer challenge. You would basically run a series of update queries on your address where you would learn about the database structure. So you would change your address to be selected from the list of table names in the database, and then you'd learn about the tables. And you'd pick a table that sounded promising, and you'd change your address to be the list of columns in that table. And then maybe you find a column that looks good, and maybe you don't. For the sake of brevity, we're going to kind of skip that process. And by happenstance, Alice is looking around, and she looks in the page source, and she finds a note from the page developer who wrote down what the query was and where the input is going into the query. So the query looks like update challenge users set address equal to what they put in this text box, where the username is Alice12345. So effectively, what we're going to do is we're going to let this statement fire. We're going to close it out, and then we're just going to write another statement to execute. And that statement will set up more opportunities for us. Again, in the interest of time, we're going to presume that we already know the table that's written here in this query, and that we already know that there's a nice am I an admin flag that's stored right next to your username in the same table and is very easy to update. Real sites, hopefully, don't do this, and real challenges would be harder than this. But this is kind of the core idea when you're given a field you can edit on a site that's vulnerable to SQL injection. So to do that, let me go to my notes because the query here gets a little complicated. All right, so we're going to update our address to 123 Alice Drive and then close out that statement with a semicolon. And then we're just going to write a new update statement. So we do update challenge to users set is admin to 1, where the username is Alice12345.
What if we didn't put the where?
If we didn't put the where, it would basically set everybody's is admin flag to be true. Which, if you're just trying to cause mayhem, that can be totally fine. Other things you can do with this kind of attack is you can drop the whole user table. You can break the site forever and delete all their data.
No one do that right now. Somebody didn't do their job.
Yeah. Me.
No, that was me.
So we run that query, and we did manage to set the is admin flag. And now we have the special link for managers only to add new coupon codes that will be accepted. How many of these did you find?
There's a whole subculture, I'm sure.
Apparently.
I mean, this was a small fraction of the live, laugh, love signs that I found.
Okay, cool.
So, Ben, we've got a question.
Sweet.
So I know that we talked about how to protect against this, but we also have a question about how other ways you would attack a site for SQL injection when you didn't, kind of have any insight into the kinds of queries that were being run, or you didn't know what the database schema or even the table name looked like. And
right.
One of the things you went over is kind of a beginning. What we've demonstrated so far is kind of trying to see if, or trying to determine if the web application is using any sort of input validation or prepared statements, or is it just running SQL queries? So but that's kind of the beginning part, is like, can I determine whether or not this application is written in such a way that it's executing SQL queries directly against the database using my input? That's your first bar. But what other, what would you do next if you didn't kind of understand what the database was doing behind the scenes?
From there, it very frequently becomes a process of trial and error, where you try out queries that might return something useful or might not. And there are frequently quite a few tools that will basically automate a lot of this search for you. You can point them at input fields, and they will try all sorts of variations on these queries, especially the ones that you might need for different databases. So, a site running on MySQL will have different queries to find out about its structure than a site running on SQL Server, different from a site running on Oracle, different from a site running on XYZ. So
that what you're trying to say is, or what I'm hearing you say is, it's a slow investigation, even with the use of automated tools.
Yeah, even with tools, it is a lot of investigating and trying to find an in. You do a lot of probing, so to speak.
And so in that sense, what you're trying to see is, okay, first you've determined that the application is not doing its job.
Right.
And it's passing your inputs directly to the database. Then you're trying to see, is the database set up in a secure way or not? Because did the database administrator give the application way too much privilege in the database to do more than it needs to, such that you can exploit that by, oh, now I can run, data dictionary commands and start modifying the schema, or start describing the schema and things like that, and start investigating.
Yep. Yeah, precisely. It's and when you're designing your sites to defend against this kind of thing, you want to adopt a defense in depth strategy. So you use prepared statements. You lock down the web user's access as much as possible. So that way, even if something slips through, you can minimize the damage that they would do. So, you can limit what users can do on certain tables, and you can say this user can only read from this table. Nobody's allowed to write or drop if they're accessing through this user.
And that's why I love the way y'all have structured these demos, is that, we talk about, okay, here's how you attack a site. The reason, and this is just a reminder from everybody, a PSA, the reason we go over these things, both in JOLT and in something like this, is so that you can understand how other people can attack your site and you can defend it. So we're definitely not promoting people attacking this, but we're promoting people understanding how sites can be attacked.
Or like if you needed to skip through a video or something.
Yeah, that.
The only sites you should be attacking are your own, so you can find where the hole is and fix it.
Or with somebody's permission, yeah.
Or yeah.
But yeah, just to reiterate, if you go to a site and you can get the page to give you junk back whenever you type something in, that usually tells you that they did something wrong on their end, and you can just usually, if you want to, you can pull on that thread and possibly get out some data that they didn't want you to get.
Yeah, and these sorts of injection attacks very frequently are like pulling on a thread, where it's a laborious process, and the first demo is a lot harder when when you don't see the query that's getting run and you can only guess at it. And this demo is a lot harder when you're not told the query that's being run, so you can only guess it. And they're both definitely possible, but it makes it harder. So real sites would not be this easy to inject, but many of them are still possible.
But you can be surprised. I mean, sites have been configured or put in production, but with the debugging flags turned on, where the information is being spit out to the developer for their use, and then that code gets put into production somehow. I mean, there are scenarios
or just find an exposed test server or something like this. There's all sorts of interesting attacks you can do. All right, I'm moving on to the last one. So now Alice is going to her local movie theater, and she sees that they have a special. And you can, whenever you buy a ticket, you have a chance of winning all the complete Beanie Baby collection. And she's really into Beanie Babies. Anyway, so she's digging around on the movie website, and she's digging around behind the scenes, and she sees that there is one address that a JavaScript function points to, like the one I showed you guys before, and it gives back something like this. So it's called verified code, and you can give it a code, and it will tell you if that code is valid. And she gets to thinking that, hey, if I just go through here and try a bunch of codes, maybe I could just figure out which one was good, and I can, camp out by the kiosk and see what tickets they're selling and try to buy just the right one so she can get all of the Beanie Babies. So, you can test these one by one. But, that gets kind of laborious, and judging by how many digits the default one came with, there might be 100,000 possibilities. So you might want to step up your game a bit. So I'm going to introduce a little bit of Python code. And so Alice put this together, a few imports, but she put the URL that she's trying to attack. Little side note, what I'm doing right now is called, I call it API abuse. So a lot of times websites will have behind the scenes functionality that they've built tools for. Anyways, in this case, they have one service called verified code, where you can, any website that needs to can pass the code and get the answer back. Real websites would have, some kind of login protection, authentication. So only legit people can call this directly. But it's not too uncommon to find unprotected APIs, and this would be one of them. And so anyways, I can go and grab all the code from that URL, and I can print it out. And here you can see that, there you go, I'm getting the result. And so now that I have a programmatic way to read that stuff, I can just go to town with a for loop or something. So I'm just gonna say for I in range 99999. All right, so I'm gonna tab all that over, and I gotta change this 0 to whatever number I wanna check. So I'm gonna say %I or %D. This is a little Python trick, and then I can insert in that number. So %D stands for a decimal number, base 10 number, and so it's gonna put whatever iteration I'm on into that slot. So now you can see that it's going through, and it's going somewhat fast.
That's pretty fast.
Pretty fast.
All things considered.
I happen to be on the same local network as this machine. if you were not, you know, the result will go down to Texas and then back. And anyways, you're gonna get a pretty long. This is gonna go much, much, much slower. And you wouldn't want to go this fast whenever you're attacking somebody for real, because if they actually have security in depth, one of the things they will have is logging and traffic analysis, and they'll see that there's too much. Somebody's doing some something fishy with this service. And
you also might be rate limited. Many APIs, you know, will only accept a certain number of requests per.
So by now I would have got my IP banned.
Yeah.
And if they're doing what they're supposed to be doing, and I could always use a VPN, go to another one. You know, I can still keep on attacking. I'm not done if I get banned. But you probably want to start on some throwaway VPNs if you're trying to do an attack like this. But that's going a little too slow. I thought I would just mention that you can thread this. And what's happening right now is it will ask for the website and wait until it gets back, and it'll do a blocking operation, which is kind of slow. So I'm waiting for the traffic to go out and then come back before I can go on to the next one. If I could just like send a bunch out and then wait for them all to come back in, I could go tons faster. In Python, they have something called thread, which most things do. So you can start up a new thread and you can give it a target. And I'm going to give it a target. It's going to be a function I haven't written yet, but I'm going to call it crack. And you can give arguments to that function. And I'm going to give it the function. I'm going to give it the thing I want it to crack. Okay, and once I get that thread, then you just have to tell it to start. That's all there is to multi-threading in Python. And so I'm going to take all that code that I had there and I'm going to put in a function called crack. All right.
You need to define like how many it's going to run.
Right now I do not. I do not have a way to limit it. So right now it's going to make maybe more than it should, and it will use up all my memory. But I think I have 16 gigs on this computer of RAM, so I'm good.
That's when Nick got kicked off the Zoom call.
So yeah, good point, Josh. I'm not going to worry about it right now, but what I could do here is I could say while I would say like threading dot active active count. I want to say I'm going to try this. While that's greater than 100, then I'll do something like time dot sleep for no time. So what that will do is it will release my thread and let other threads finish off until that number gets below 100, and then it'll go on and spawn new threads as it gets time. So anyways, we'll see if that even works. But what line? Oh, this is threading. All right, this is going a little faster, and I'd get blocked way faster now. And I still don't want to wait until I actually get through all 99,000, but this is something you can set and then go away. And you can make it, you know, only do so many in a certain amount of time, and then just have it robotically go through those while you're not sitting there waiting for it. I happen to know that the answer is somewhat bigger than 60,000. So I'll just start at 60,000. And I don't want it to print every single one of them. So right here it says is valid 0. I'm guessing it would say is valid 1 if I get the right one. So I'll just come in here and put a little if statement. I'll say, hey, if is valid 1 is in my text, go ahead and print that out, and I should be good to go. So I'm going to start at 60,000 and go to whatever number. So there we go. Anyways, this is more complicated than it needs to be, but what did I do wrong? Oh, I know exactly what I did wrong. there's a difference in Python 3 between strings and byte strings, and I need what's called a byte string here. So I'll wait, twiddle my thumbs a little bit, hope for the best.
While we twiddle our thumbs, I'll give a quick story. At previous JOLTs, I was very fond of, taking a challenge that needed quite a bit of computation power, throwing it in a multi-threaded Python program, giving it about half the CPU, and then going and working on other things.
All right, we got the code is 69420. And I'm going to go manually verify that now that I cracked it. So go back to here and
It's also his Xbox gamer tag.
69420. And huzzah, it's valid, and I can. Anyways. I hope I shared the sound on that one.
Oh yeah, you did.
Oh yeah.
Anyways, Alice's boss, she's made it, and she's got her beanie babies. All right.
My retirement fund is complete.
Anyways, Alice has accomplished all that she wanted for this week. But I thought I'd do a little wrap up for some of the main things that are web vulnerabilities. So the number one web vulnerability is injections. That could be JavaScript injection or SQL injection. Anyways, you shouldn't trust code that somebody else gives you, but that's still the number one thing that people exploit. The next thing is whenever people don't have, they've tried to roll their own access control, or they set a folder, they forget to set who has rights to different things. You can imagine when you're dealing with tons and tons of data and different people have access to different parts of it, it's easy to get somebody with the wrong access, and that's just a human thing. So all the times people are getting into a website and they're just seeing that they can see something they shouldn't be able to see, which goes along with the third one here, sensitive data exposure. So and this is more on the API side is what I think they're talking about, but there's tons and tons of exposed APIs that can give out information that they shouldn't give out. And if you can get in there and scrub it with a robot, all that data is yours. And then the last one, which I wish we had an example for, but this one gets a little bit beyond what we can do in a session like this. And you need some tools beyond the browser. And this is cross-site scripting. So imagine you come to a website that has a chat feature, and they don't scrub JavaScript out. So you can chat and then throw some JavaScript in there, and then somebody else can come to that same site and see the conversation, and it'll run your JavaScript on their machine. And you can do all sorts of things like steal their cookies and take over their sessions with session hacking. You can just control what they're doing on that site. Say it's a bank account, you can have them transfer money over to you. Insert any number of things, anything that user could do, now you can do, and you can masquerade as them. Anyways, one thing I wanted to mention, if you guys want, something to grab onto and go from here, is OWASP has put together a really cool online demo called JUShop, where it's a really horribly put together store. You can go in there and it has every single vulnerability you could think of. And so it's a way to practice all of these things and more. So yeah, look up OWASP JUShop. You can host it yourself and run a local version, but they do have an online demo. If you Google that, you should be able to find that. That brings me to the end. Do we have any questions?
This is your chance to ask questions. You can ask them in the chat or pop open the Q&A tool and ask that. Any questions we received in the Q&A tool should be listed in the Answered tab there. We've tried to document that there.
Special shout out to all the good people that followed along the demo and didn't break the website that the demo was using.
I appreciate you.
Yeah.
That was on my to-do list to like disable drop access to the user, but somebody didn't do that. That just goes to show you that laziness causes a lot of these problems.
Let's see, I've got a question coming in here. Nick, can you just quickly cover what byte strings were, and why was that an issue? What
Sure.
what were you searching? And
Sure. So in the olden days of computers, we were very English centric. And so all of the characters were just Roman characters, just characters that we have on our keyboard. But we have progressed and we're in the future now. And you have to be able to have strings with kanji characters and other random stuff like this. And so beyond just the 128 possibilities that ASCII provides. So a byte string limits you to every single character is a byte. So it has to be some value between 0 and 255. So let me share my screen. So here, whenever I asked for that website came back as a series of bytes. Whenever I said .read, it's going to give me all the bytes that came from that website. If that website wasn't encoded in ASCII, then I would have to decode it using UTF-16 or something like this. But it was in ASCII or UTF-8, so I didn't have to do anything with it. So I could have said decode. I think UTF-8. I don't do this very often, but then I can take off the byte string and compare real strings, not byte strings. Let's see if this works. It doesn't complain at me, so I'm gonna say it's working. So
by default, modern programming languages try and start out as treating something as a byte string, almost like this is an unknown. I'm not going to make any decisions about this. I'm just going to go byte by byte and look at the, as general a table I can, right?
If you're reading from a file, typically it's going to come in as bytes, and then it's up to you to say no, these aren't bytes. This is something else.
Perfect. Stephen, did that answer your question? If it didn't, let us know. Excellent. Anyone else? I love the breadth of this session, because even at the end there, we've got to see some coding, and that is definitely something that has always been a way to defeat certain challenges at JOLT. Is sometimes you have to put a little scripting in. You need to automate something like Nick did, because otherwise you'd be spending the entire 24 hours picking number after number after number. And so those are often useful skills to bring to the table or on your team. Somebody who has a little scripting or some programming skills can be a real benefit on a JOLT team.
Yeah, we love the needle in the haystack kind of problems.
Exactly.
You're in a maze and you have a million passages and you go left or right. Go find the flag in this HTML maze. Like you could do it by
flashbacks.
You could do it by hand, or you could code it to like explore all possibilities.
Mm-hmm. Do it by hand, or you could live through the event, whatever you want to do.
Or you could let your neighbors do it, look over their shoulder, and then get no, don't do that.
Yeah, don't do that. No, but we routinely build challenges specifically to get people to stretch those scripting muscles.
Mm-hmm. Yeah, those are the exact kind of puzzles that are good for code up a script that runs in the background while you go tackle other challenges, and then check back in every 15 minutes and see if you've gotten an answer yet.
Then check back and engage your disappointment.
Yeah, exactly.
And see if we've been sneaky to rate limit you while you're doing that.
In finding vulnerabilities, if you can script, checking different sites, you'll be able to find those faster than manually checking site by site, if you have an idea what the vulnerability is.
One of our challenges is always creating puzzles that can't be so easily solved with some of the tools and the kind of bundles that are out there that like Ben was referencing, you know, there are tools that will sit there and do their best to try and bypass certain types of databases and things like that. So our challenge is always write them so that that's not going to help you. It might get you something, but it's not going to get you the whole thing. So that's where this kind of understanding of how APIs work, how to reach out and parse data, how to look through the inspector or the developer tools, and especially how to run JavaScript there locally against a site that we've given you are really, really powerful skills to bring. And again, this whole thing is not that you necessarily have to show up to JOLT with these skills, but that you leave with a stack of things that you're interested in and that you want to investigate further. And we've heard a lot of feedback along those lines too. So that's where the heart of this JOLT.ed series came from, is we wanted to give back and keep that conversation going throughout the year. So speaking of, be sure and join our Discord community. We want to keep talking to you. We want you to talk to each other. That'll be the best place to get the most recent information about the future of this spring's JOLT or possibly even more sessions like this. This is all done as a labor of love from the Game Masters and with the support of the Venture Center, but it's something we feel important enough to do. So I really want to thank everybody for attending. With no other questions, I'll hand it back to you, Ashley, to wrap us up.
Thank you so much. Not a whole lot left to go over. Just want to share this nice little graphic that shows what the final session is about. We'll welcome Chris back and have been back for this fourth and final session on reverse engineering. Again, that is next Friday, October 30th from 11 to 1. So be sure and register for that. And we hope to see you there. Before we go, just one final thank you to our sponsors, Simmons Bank, the Little Rock Regional Chamber, Frost PLLC, Mainstream Technologies, Wright Lindsay Jennings, Euronet Worldwide, and First Orion. Thank you guys so much for sponsoring. Thank you all for tuning in to this session 3 on web vulnerabilities. We hope to see you again next week. So thanks again, guys, and we'll stay in touch on the JOLT Discord channel. Thanks, everybody.
Thanks, everybody.